These are your instructions. In general, you just need to follow the PowerPoint. Make sure the sound is turned up on your device so you can hear the narration. Your instructions are in yellow boxes on each slide. If a slide asks for homework, don't forget to send it in via Show My Homework to your science teacher. This is our starter activity. In physics, we define work as something that is done when a force moves through a distance. Stop the recording here and see if you can answer this question. You should have realized in the first case, no work is done because the wall doesn't move. Whereas in the second case, work is done as the boy is moving the rock. These are our learning objectives. We want to define work as energy transferred when a force moves an object. We want to be able to draw a diagram to explain how a lever makes a job easier. We want to compare the work needed to move objects over different distances. And we want to apply a formula for work done equals force times distance. In physics, work is done and energy is transferred when a force moves an object. The bigger the force or distance, the greater the amount of work done is. Here are some examples of work being done. The man is doing work against friction. The further he pushes the box, the more work he has done. The lady is doing work against gravity. The heavier the weight is, the more work she has to do to lift it. Another way of thinking of work done is as energy transferred. When the man pushes the box, he is transferring energy from his chemical energy store, which he gets originally from his food, to the kinetic energy of the moving box. When the woman lifts the weight, she is transferring energy. She is transferring her chemical energy from her food to the gravitational potential energy of the weights because she's lifting them up. You should remember from your lesson on energy stores and transfers that there are 4 ways that energy can be transferred. There are 4 pictures on this slide, and the 4 methods of energy transfer are shown in red. See if you can match them up. You can check your answers using the information in this table. There are 4 methods of energy transfer that you need to know about. The first is heating, whenever energy is transferred from a hot object to a cold one. And a good example of this is a pan on a hot stove. Remember, in this case, the energy is always transferred from the hotter object to the colder one. The second method of energy transfer is mechanically. This is defined as whenever a force does work. Good examples of this are pushing a box or throwing a ball. The third method of energy transfer is through light or sound. Sometimes these are referred to as radiation. This is when energy is transferred by light or sound waves. And this is how the Earth receives its energy as light from the sun. The final method is electrically, whenever a moving charge does work. So for example, when electrons flow around a circuit and a current flows, that is electrical transfer. Whenever energy is transferred mechanically, we can work out the work done or the energy transferred using this simple formula. There are 3 terms in the formula. Work done equals the force that is applied times the distance that is moved. And these are usually labeled this way. W is for work or energy transferred in joules. The force is F in newtons and the distance moved is S in meters. Here is a worked example. A cyclist pedals a bicycle with a force of 1000 newtons and moves it 250 meters. To calculate the work done, we know our formula, work done equals the force times the distance. In this case, the force is 1000 newtons and the distance is 250 meters. If you multiply the 2 together, you get the work is 250,000 joules. Now that looks like a really big number. So if you divide it by 1,000, you'll come up with 250 kilojoules, because a kilojoule is 1,000 joules. Here is a second example. A car engine moves a car with a force of 10 kilonewtons, that means 10,000 newtons, and does 500 kilojoules of work. A kilojoule is 1,000 joules. How far has the car travelled? In this case, we need our formula, work done equals force times distance, but we need to rearrange it because this time we're trying to find the distance. So the distance is equal to the work done divided by the force. Now we can put our figures in. 500,000 joules divided by 10,000 newtons gives us an answer of 50 meters. When you're doing questions, you have to be careful that you're using the right units. Remember that a kilojoule is 1,000 joules and a kilonewton is 1,000 newtons. There are lots of interesting examples of energy transfers and work done. One of the most interesting is roller coasters. Follow this link now to watch the video. Now it's time for you to calculate the work done for some real rides. The first one is a roller coaster called Stealth. The force is 8,000 newtons and the distance it moves is 34 meters. See if you can work out how much work is done. If you can work out how much work is done when the Colossus roller coaster, which weighs 90,000 newtons, moves vertically through a distance of 30 meters. Your third example is not really a roller coaster, but the same principles apply. This time, the weight is 40,000 newtons and the distance it moves is 35 meters straight up or vertically. See if you can calculate the work done. Green pen your answers using the information on this slide. There are some simple machines that make it easier to do work. They work by reducing the force needed to lift or move things. We need to look at a few examples. Our first example is wheels. Just think how much more difficult it would be to move your shopping trolley if it didn't have wheels on the bottom. Wheels work by reducing friction. There is less friction between a rolling wheel and a surface than between a sliding object and the same surface. Our second example is a lever. A lever is what we call a force multiplier. One end of the lever moves much further than the other, and this increases the force applied. A good example of this is using a long handle screwdriver to open a paint can. Our final type of simple machine is something called a pulley. Simple pulleys work by changing the direction of the force. If you look at the picture, in order to raise the weight, it's much easier to pull down using your weight than it is to actually pick up the weight and lift it. Here are some key terms that you need to record and learn. The next slide contains your homework. In your book, put a title of Work Done Homework and send your answers to questions 1 to 5 to your science teacher. The deadline for this work is Monday, the 18th of May.